American business moves on its wheels, carrying building materials for homes and business, chemicals for its industry, fuel for its furnaces. And when America needs to stop safely, predictably, no matter the conditions, America chooses Rockwell air disc brakes. Rockwell air disc brakes, one of the finest, most dependable brake systems available in North America today. In fact, in their recent study, the National Transportation Safety Board recommends that air brake component manufacturers develop, promote, and install brake systems that are less sensitive to adjustment and more resistant to brake system fade, such as long stroke chambers and air disc brakes. But as with all mechanical systems, you've got to maintain them. And that's what this video is all about. We're going to discuss some specific maintenance issues that many of you have been experiencing. Chamber hangup, rust contamination, caliper drag, and we're going to answer questions about lubrication and the installation and adjustment of automatic slack adjusters. To prepare this video, we went to where the action is, out into the field, to hear from you, the professional working technicians, to learn just which problems you would like help with. Then we'll cut back here to Rockwell headquarters in Troy, Michigan, and show you how to handle them. Now, you'll need your normal shop tools and some specialized tools from Kentmore, and most importantly, you'll need your copy of this air disc brake manual. This is the most important single tool that you'll work with. The Rockwell International Air Disc Brakes Maintenance Manual number 4M. In contrast to a lot of technical manuals, this one is easy to understand. It fully explains how to work with all of the components of Rockwell International's air disc brakes, and the illustrations bring it all together. We'll be using it throughout this video to show you the repair procedures. Learn to use it. It'll be the best tool you have in the shop. The Rockwell air disc brake is the only brake system of its kind in production in North America, and its unique performance features include dependable braking performance, resistance to fade, excellent directional stability, and wet weather performance. And this Rockwell brake system was designed with you, the maintenance technicians, in mind. It features a fully sealed actuating mechanism, external lube fittings for routine servicing, self-cleaning design to inhibit contaminant wear, swing-away caliper with lift-out shoe assemblies for quick lining changes, and the Rockwell automatic slack adjuster. And we're constantly improving this system as we listen to you, with asbestos-free lining compounds that cover a full range of operating temperatures, shoe and lining assemblies that now have an anti-rattle clip that pivots in the middle to prevent wear, which can cause annoying chatter. And we've added an additional lubrication fitting on the caliper to transport grease directly to the actuator piston. During this video presentation, we'll be discussing the operation and service of the Rockwell air disc brake model ADB 1560. Now, you're no doubt aware that there are two other models. There's the ADB 1540 and the ADB 1760. The number refers to the nominal diameter rotor size and its nominal square inches of lining area. For example, the system that we'll be working on, the ADB 1560, has a 15-inch diameter rotor with a lining area of 60 square inches, thus the number 1560. The ADB 1760 has a 17-inch nominal diameter rotor and also a 60 square inch nominal lining area. Now, regardless of the number, the operation and the service procedures that we will be discussing will remain the same for all models. You're also aware that there are two types of rotors. They're solid and vented. Now, the brake system that we'll be working with has a vented rotor. Incidentally, Rockwell recommends the use of gray iron rotors on all steer axles and straight truck drive axles. However, we recommend the usage of ductile iron rotors on all tractor drive axles and trailer axles. Now, before we get to the actual maintenance procedures, let's go over the operation of the brake itself. Now, when the brake pedal is applied, air pressure is directed to the air chamber. Now, this air pressure pushes the diaphragm, forcing the push rod of the chamber outward. Now, the push rod pushes the automatic slack adjuster, rotating the power shaft. Now, the rotating power shaft causes the power shaft nut to travel outward, pushing the brake piston. The piston, in turn, pushes the inboard lining against the rotor. Simultaneously, upon contact with the fixed rotor, the caliper is forced inboard, pulling the outboard lining against the other side of the rotor, like a C-clamp. The result? A solid, secure clamping force on both sides of the rotor. At the front end of this unique brake is the automatic slack adjuster. Now, you've asked us a lot of questions about it and its installation, adjustment, and particularly using the template. So, let's get to it. First, we'll review the slack adjuster's operation. As I stated, when the foot pedal is applied, it increases the air pressure in the air chamber, which pushes the push rod outward. The clevis, located at the end of the push rod, pivots on the automatic slack adjuster arm. And the slack adjuster rotates the power shaft, ultimately causing the rotor to be seized by the clamping action of the linings. And of course, another key feature of the adjuster is that it automatically adjusts for lining wear, thus minimizing frequent manual adjustment. It's a pretty straightforward system, but it has to be installed, adjusted, and maintained properly. Rockwell has provided you with a video dedicated to the selection, installation, and maintenance of this automatic slack adjuster.
The pawl assembly could be damaged, so remove the pawl and check for wear or grease contamination. If a quick connect collar is used, check for excessive wear between the clevis and the collar.
It's number 90234. You'll find it to be very helpful. Now, let's take the first of several questions from the field. We went to Waste Management Corporation and Air Products Corporation in Lancaster, Pennsylvania. Let's start with Air Products Corporation, who operates and maintains a large fleet of trucks, and they've got a lot of experience with air disc brakes, but they also have questions. Let's hear the first one.
Would you go over the installation of the automatic slack adjuster and how you actually adjust it for over-the-road service? I would also like to know how to use the template when installing and adjusting the slack adjuster.
Good question. Proper installation and adjustment are critical to the correct operation of slack adjuster and brake. And I'm glad he asked about the template. It'll save you a lot of time while it eliminates the guesswork. Let's get to it. We'll install and adjust an automatic slack adjuster using this template to show you the right way to do it. This will make it easier for you in the future. Oh, incidentally, Ray Clausen of Rockwell International will be helping me out with the processes that we're discussing. Thanks, Ray. Incidentally, if you are relining or overhauling a brake, you must adjust the brake before you return the vehicle to service. Use the following procedure that's outlined in your manual. Check the table of contents. There it is, adjusting the brake. Preparations before adjustment. These instructions and drawings will walk us through step by step. First, if the brake has a spring brake, use compressor air or manually compress and cage the spring so that the brake is fully released. Warning: carefully follow the service instructions supplied by the manufacturer of the spring brake when you work on this component. The spring brake can activate and hit you with enough force to cause serious personal injury. Now, make sure that there is no air in the service half of the air chamber while you adjust the brake. Next, check to be sure that you're working with the correct template for the brakes you're servicing. The green template is for offset clevises used on front brakes built before December 1989. And the yellow template is for use on all front and rear brakes with straight clevises. Incidentally, you need new templates? You can get them by calling us at 800-535-5560. Now back to the adjuster. It's important that you use the right template. If you use the wrong one, the slack adjuster will not maintain proper adjustment. Now we're working with a new brake with straight clevises, so we'll use the yellow template. Some important comments on safety procedures. As a warning, we recommend that you always wear eye protection to prevent serious personal injury when you're working on vehicles, and an air purifying respirator when you work on linings. We also want to warn you that some brake linings contain asbestos fibers, a cancer and lung disease hazard. Some brake linings contain non-asbestos fibers whose long-term effects are unknown. Caution should be exercised in handling both asbestos and non-asbestos materials. Pages 2 and 3 of this manual give you important information on these and other related safety matters that you should know, understand, and implement. Now, let's start the installation of the automatic slack adjuster clevis. Install the jam nut on the air chamber push rod. Turn the clevis onto the push rod. Now adjust clevis setting. Place the small end of the template against the bottom of the air chamber. Screw the clevis inward toward the air chamber until the center of the large hole for the large clevis pin is on line with the mark on the template. The hole should be 66.5 millimeters or 2.62 inches from the bottom of the air chamber. The push rod must seat in the clevis within the following limits. The threads of the push rod in the clevis must engage at least 1/2 inch, but must not extend more than 1/8 inch through the clevis. If necessary, shorten the push rod by cutting. A word of caution: be sure to always follow the chamber manufacturer's directions for this operation. Failure to do so could result in a leaky air chamber. Now, securely tighten the jam nut with a torque wrench. The torque specs can be found in Manual 4B. There they are. Torque set for both 1/2 inch 20 and 5/8 inch 18 threads. Now, clean the splines of the slack adjuster and the power shaft. Apply anti-seize compound to the splines. Use Rockwell lubricant O-637 or its equivalent if the slack adjuster was built before March 1990. But if the automatic slack adjuster was built after March 1990, you will see a groove in the center of the spline gear. It won't be necessary to use anti-seize compounds at this point, as you would on earlier models. The groove that I just mentioned and the grease channel have been added to the automatic slack adjusters to assure that grease gets to the power shaft splines for smooth rotation during regular operation. This also prevents corrosion or rust buildup at the power shaft splines. This is an issue that we'll deal with later in this video. Now, install the slack adjuster onto the power shaft of the air disc brake assembly. Install the spacing washers and the snap ring. There should be a maximum clearance of 62 thousandths of an inch. That's 1.57 millimeters between the washer and the snap ring. Give it a shot of grease. Remove the pawl from the slack adjuster, or you will damage the pawl teeth when you rotate the adjusting nut in a clockwise direction. On automatic slack adjusters equipped with the pull pawl feature, it is not necessary to remove the pawl. Instead, use a screwdriver or a Kentmore tool to lift the head of the pawl away from the body of the slack adjuster, but hold it while you turn the manual adjusting nut. Now, turn the manual adjusting nut counterclockwise until the hole in the arm lines up with the large hole in the clevis. Place the template against the slack adjuster. Line up the small hole at the small end of the template with the center of the power shaft. The top large template clevis hole should match with the large clevis hole of the slack adjuster. If not, make the necessary minor adjustment by readjusting the clevis after you've moved the slack adjuster out of the way. When everything lines up, remove the template and the clevis pins. Incidentally, the pictures in the manual graphically show this procedure. Now, apply Rockwell anti-seize compound on the clevis pins and slack adjuster. Install the clevis pins. Insert new clips or cotter pins to hold the clevis pins in place. Slack adjuster installed, quick and easy. Now, we're ready to adjust the free stroke. Before I go on, let me mention that there are two different types of strokes that you'll be dealing with when adjusting the brakes. First is the initial free stroke. Essentially, the initial free stroke setting is the gap between the linings and the rotor. As is always the case when working on the automatic slack adjuster, be sure the pawl assembly is removed or lifted away and disengaged if equipped with the pull pawl feature. Now, the first step is to set the clearance between the inboard linings and the rotor. Turn the manual adjusting nut counterclockwise until the inboard lining and rotor make contact. Next, back the lining off from the rotor by 3/4 of a turn. This will be the first of two measurements, and it defines the distance of the large clevis pin from the bottom of the air chamber when the brake is fully disengaged. Measure the distance from the chamber face to the center of the large clevis. Then, contact the rotor by inserting a pry bar between the two clevises and pulling back until the linings and the rotor are engaged. Now, measure the new distance between the bottom of the air chamber and the center of the large clevis. The difference between the two measurements is the length of the free stroke and should measure between 3/4 to 1 inch. A word of caution: don't set the free stroke shorter than the specified length. If the free stroke is too short, the pads can drag on the rotor and damage the brake. You can also use the yellow template to measure free stroke. Put the narrow end of the template against the bottom of the air chamber. The center of the large clevis pin must be at the mark on the template, indicated CL, a large clevis pin. Then, using our pry bar, move the slack adjuster so the linings and the rotor fully contact. The center of the large clevis pin must now be between the minimum and maximum marks. If the free stroke isn't within the required specification of 3/4 to 1 inch, there's a quick corrective action you can use. To shorten the stroke, turn the adjusting nut counterclockwise in 1/8 turn increments. Check the length of the stroke and repeat until the proper gap is achieved. To lengthen the stroke, turn the nut clockwise and conduct the same procedure. Now it's time to double check the installation of the automatic slack adjuster and operation of the brake by measuring the adjusted chamber stroke. Measure the distance from the bottom of the air chamber to the center of the large clevis pin while the brake is in a disengaged mode. Now have someone apply pressure to the brakes, achieving 80 to 90 psi at the chamber. Now continue the procedure. With the brakes applied, make the same type of measurement you did when you determined the free stroke. The difference between the two measurements is the adjusted chamber stroke. It must be less than the amount shown in the manual. It's based on the brake's chamber size. Be sure you consult this table to determine the proper chamber stroke for air disc brakes. If the chamber stroke is too long, shorten the stroke by turning the manual adjusting nut counterclockwise in small increments, or lengthen the stroke by turning the adjusting nut clockwise. Repeat the process until the differential between the two measurements is less than that shown on the chart. Again, don't make the stroke too short or the lining will drag on the rotor. Now, install the pawl assembly or release the pull pawl by removing the tool, tightening the cap screw to a torque of 15 to 20 pounds-foot or 20 to 27 Newton meters. Finally, if the vehicle has spring brakes, uncage the spring. And you're done. Slack adjuster installed and brake adjusted.
Throughout the manual, you have references as to where to apply the grease and the anti-seize. Will you tell me what I need to grease and what needs anti-seize? I don't want to miss anything when I'm servicing the brake.
That's a good point. The manual does tell you what to grease and where to apply the anti-seize compound too, but it may be easier for me to bring it all together for you. But first, be sure to use the grease specified in this maintenance manual 4M, and be sure to use the same grease on the inside parts of both caliper and the automatic slack adjuster. The grease must meet all of Rockwell's specifications. And, of course, the anti-seize compound must also adhere to the specifications in the maintenance manual. When you need anti-seize compound, use Rockwell Lube Spec 0637 Part 2297U 4571 corrosion control grease or an equivalent. To understand all of the lubrication requirements, refer to Rockwell Maintenance Manual number 1 or number 4. They will both tell you what you need to know about lubrication. Now, let me quickly review the lubrication needs by component for you. Let's first see the lubricating requirements of automatic slack adjusters. Use a grease gun to lubricate through the grease fitting until grease flows from the pressure release valve in the pawl cap screw. Remember, if the automatic slack adjuster was built prior to March 1990 and doesn't have a grease groove in the spline, during installation you'll have to apply anti-seize compound on the spline instead of grease. And apply anti-seize compound to the clevis pins. That's it for the automatic slack adjuster. Now, let's go to the lubrication of the caliper. First, let me point out that you need to lubricate the brake actuating components 2 times during the life of the brake linings or every 6 months. And we caution you to make sure you don't get any grease on the rotor or linings. Grease will cause poor brake performance. Now, let's get on to the lubrication itself. Since 1981, Rockwell air disc brake systems have been manufactured with 3 different designs. The location of the grease and relief valves are different in each case. Therefore, we need to cover each one. The first 3 steps are the same no matter which of the 3 models you're working on. First, always remove the pawl assembly or disengage the pull pawl of the slack adjuster to prevent damage. Next, turn the manual adjusting nut counterclockwise to move the inboard lining against the rotor. And apply the grease. Now, brakes manufactured before 1985 will look like this. Apply the grease through the grease fitting in the caliper until it flows from the relief valve. Next, hold down the relief valve. Continue to apply grease until new grease flows from the seal at the power shaft cap. Now, force any excess grease from the caliper. Too much grease or air inside the caliper can cause the linings to drag on the rotor. If this situation occurs, remove the relief valve from the caliper. Turn the adjusting nut clockwise to retract the inboard lining and the piston from the rotor, thus forcing the excess grease or air through the hole of the relief valve. Now install the relief valve. Clean any excess grease from the outside of the caliper. And finally, adjust the free stroke and the applied stroke. Now, let's move on to the brakes manufactured between 1985 and mid-1992. First, remove the pawl assembly, or disengage the pull pawl and rotate the inboard piston and lining against the rotor. Now apply the grease through the fitting in the caliper or the power shaft cap until grease flows from the relief valve in the caliper. Remove the relief valve from the caliper. Turn the adjusting nut clockwise to retract the inboard lining and piston from the rotor, thus forcing excess grease or air through the hole of the relief valve. Now install the relief valve. Clean any excess grease from the outside of the caliper and adjust the free stroke and chamber stroke. Finally, let's discuss the latest brake model, brakes manufactured from 1992. These units are equipped with 2 grease fittings. First, apply grease through the fitting in the caliper until grease flows from the relief valve on the caliper. Second, apply grease through the fitting in the power shaft cap until grease flows out from the power shaft. To ensure adequate running clearance between the lining and rotor, you will need to purge excess grease. To do this, remove or pull the pawl from the slack adjuster and back the caliper off. Now, turn the slack adjuster to adjust the lining clearance, as I explained earlier, and replace or release the pawl. Clean the excess grease from the outside of the caliper. And remember, since this has the new slack adjuster built after March 1990, routine slack adjuster greasing will take care of the spline lubrication requirements. As far as other lubricants, apply a lightweight lube, such as CRC or WD-40 on the caliper slide pins. And apply anti-seize compound to the slide pin retainer only. Caution: don't put any anti-seize compound on the threads of the retainer or the slide pin. This would act to collect dirt and cause caliper binding. And finally, when replacing the rotor, apply lubricant to the spindle and inside the wheel or hub. If the wheel bearings are lubricated with grease, force grease between the rollers.
Occasionally I get a driver complaint that one wheel's running hotter than the other ones. What's confusing about this is that the braking power is just the same as always. Can you explain to me what's happening there and what I can do to fix it?
As you described the problem, there are several probable causes that fall under 2 categories. They are chamber hangup or caliper drag. Chamber hangup can occur when the diaphragm plate in the air chamber isn't completely seated, causing the parking brake to remain partially engaged, causing drag and thus hot brakes. To determine if this is the case, if the unit is equipped with an inspection plug, remove the plug on the back of the air chamber. If during your inspection you see the spring lining to one side and not fully seated, it means the spring is hung up, preventing full compression, causing the brakes to be partially applied. It is necessary to replace the combination air chamber if this condition occurs. We also want to warn you again that the spring is under tremendous pressure and any attempt to take the chamber apart may cause serious injury. Be sure to check the air chamber manufacturer warnings before you remove it. Replace the chamber with one of the same size. Replace both chambers on the axles with the same manufacturing design to maintain proper function. If you originally looked inside the chamber and saw that the diaphragm spring was fully seated on the cone and that the spring was completely compressed, the condition you're tracking wasn't caused by chamber hangup. So now you've ruled it out. Let's move on to the other cause of this condition, caliper drag. Caliper drag is the result of an incomplete caliper return on the slide pin, or it's caused by a failure in the power screw to return the caliper to the release mode. In either case, the caliper's hanging up, not withdrawing completely to a fully disengaged state after braking. That's why the drivers aren't complaining about the braking action. The braking's okay. It's the incomplete caliper return. Let me show you how to diagnose this problem. Block the wheels, lift and brace the axle you're working on. Completely release the parking or spring brake. Rotate the wheel. If the wheel rotates freely, it may be an intermittent problem. This condition is most likely caused by debris on the slide pin, preventing free movement of the caliper, or worn bushings causing the caliper to bind on the slide pin, preventing free caliper movement. If the wheel continuously drags, perform a visual inspection. Look for obvious irregularities and inspect the automatic slack adjuster and caliper. Check the caliper slide pin for excessive debris that could be preventing the caliper from returning to a release position. Make sure to clean the slide pin of all debris. To assist in obtaining free movement of the caliper, Rockwell International has designed a slide pin return spring. It is available through authorized Rockwell OEM dealers and warehouse distributors, and it's in all new lining replacement kits. To install this spring, simply remove the upper slide pin. 3 notes of caution. We recommend this spring be installed in only this one location. Use this spring only on slide pins without O-rings. Always ensure that your slide pin is not worn and is cleared of debris. Install the spring on the outboard side of the slide pin and retorque the retainer. Let's look deeper into caliper drag and conditions that could be causing it. The first condition is when something prevents the free movement of the caliper along the slide pin, or there is a failure in the power actuator assembly to return the caliper. Let's investigate the first condition, the lack of free movement of the caliper on the slide pins. There are basically 2 situations that would cause this condition. First, debris, paint, or other contaminants on the slide pin, causing the caliper to not move freely. Or excessive caliper bushing wear, causing binding as the caliper moves on the slide pin, also preventing free movement. Let's look at the issue of contamination. Put a pry bar between the outboard caliper boss and the torque plate. Push or pull the pry bar. If it loosens up and free movement is restored, you found the problem. To correct the condition, clean the pins, both top and bottom. Spray a lightweight oil, CRC or WD-40 on the pins. And check the slide action again with the pry bar to verify free movement of the caliper. Incidentally, be sure to always use a lightweight oil that will provide lubrication without collecting debris. A heavy oil or grease or anti-seize compound will hold contaminants and bind up the caliper again. A quick note, it may be necessary to remove the caliper and fully clean the pin and caliper bushings if the contamination is severe. The second reason for binding may be the result of caliper bushing wear, causing the caliper to bind or hang up on the slide pin. First, it will be necessary to remove the caliper. Your manual will show you the steps for this procedure. Now, inspect and clean all 4 bushings. Use a plug gauge J34064-53 to check for bushing wear. If the gauge fits into any bushing, it's time to replace all of them. If you don't have a gauge, measure the inner diameter of each bushing in at least 3 locations. Replace the bushing if the inner diameter is more than 1.52 thousandths inches or 26.72 millimeters. Care should be exercised in removing the bushings so as not to bend the caliper bosses. They could add to the binding problems. Remember, if one bushing is worn, be sure to replace all 4. If you don't, pin alignment problems could occur. Before we remove the bushings, we should stop and review the warning on wearing eye protection. You should wear safe eye protection when you remove bushings. Do not hit steel parts or steel tools with a steel hammer. Steel can break into small pieces and cause serious personal injury. Use a brass or lead mallet. Now, let's get started. Support the caliper boss when you remove the bushings. The force used to drive out the bushing can bend or break the boss if you don't. Use the proper bushing driver and a press or mallet to remove the bushing. Now, check the bore for wear or damage. Of course, you'll repeat all of these steps when you remove and replace all of the bushings. Now, clean the bore. Measure the inner diameter at 3 locations on each bore. The diameter must be within limits of 1.118 to 1.120 inches or 28.397 to 28.448 millimeters. If the measurement exceeds 1.120 inches, you must replace the caliper. Again, a word of warning for eye protection's sake. Be sure to use a brass, leather, or lead mallet, along with wearing safety glasses when working on the bosses and the bushings. Remember, always use the replacement bushing kits described in the manual. Okay, now, let's install the new bushings. Be sure to put the correct bushing in each bore. They shouldn't be too long or too short, but should be as long as the bore is deep. And you must always use the correct bushing drivers to install new bushings. You'll need the Kentmore driver's part number J34064-52 for the outer bushings. Or, if you want to make your own drivers, the specifications are in your manual. Install the outer bushings first. Remember, use a mallet or press and be sure to support the boss. Use the inner bushing bore for correct alignment. Carefully tap or press the driver until the bushing is in the center of the bore. Remember, the bushing must not extend beyond either side of the boss. When installing the inner bushing, use the newly installed outer bushing to assure proper tool alignment. Now, check the size of the inner diameter of the bushings. If the diameter is less than 1 7/1000 inches or 25.7 millimeters, it will be necessary to ream the new bushing. Reamer tools can be obtained from Kentmore. Note, if your slide pins have O-rings, the bushing diameter should not be less than 1 12/1000 inches. Now that the worn bushings have been replaced and pins lubricated, test the motion of the caliper. Looks good. Well, that should clear up the issue if the bushings were the reason for the caliper drag. You know, a few moments ago I said that there were basically 2 reasons for caliper drag. It's either dragging on the pins or there are contaminants in the power shaft actuator. While not particularly common, you will see in older air disc brakes situations in which water has entered through a seal or a boot. To correct this situation, you're going to have to tear down the brake. So, Let's get to it and learn what's happened to the actuator. First, remove the caliper. Section 5 of the manual will walk you through the steps if you haven't done this procedure before. You'll look for rust on the piston because water has entered through the piston boot or the piston seal. To correct this condition, use snap ring pliers to remove the snap ring from the piston bore. It's a good practice to replace the seal when you service the piston, so throw this one away. From this point on, look for signs of rust and/or contamination. If you find it at this point, continue the teardown because there may be more. Now, remove the spring retainer. First, assemble the adapter tool. If you're working on a brake that has a disc vent, install a spacer over the bearing. Put the adapter tool directly over the spring retainer. Turn the nut on the adapter until you release the return spring pressure on the snap ring. Use 45-degree snap ring pliers to remove the snap ring. Now, turn the nut in the opposite direction to release the spring pressure. Completely retract and remove the tool while you hold the spring retainer. Remove the spring retainer and return spring. Remove the piston from the caliper. While you remove the piston, remove the lip of the boot from the groove in the piston. The boot will remain in the caliper bore. If you're working on a brake with a solid disc, you will have to retract the power shaft before you remove the piston. Next, remove the boot and the O-ring with a screwdriver or other type of flat blade tool. Throw the boot away. You'll install a new one when you reassemble the caliper. If you did find any rust or contamination that would prevent the power shaft actuator from working properly, you'll have to remove the power shaft. Don't reassemble the piston, O-ring, and boot at this time. You'll do that after you've worked on the power shaft. Now, let's remove the power shaft. Remove the cap screws and washers that hold the power shaft cap and the air chamber bracket to the caliper. Remove the bracket. Lift the power shaft and the cap and nut assembly out of the caliper. Be careful not to turn the shaft or the nut will fall off the end of the shaft. Use snap ring pliers to remove the snap ring from the power shaft. Remove the dust cover from the power shaft. Separate the cap from the power shaft. Remove the nut and washer. Look for rust or other contamination on the power shaft, particularly around the journal here. Also, look in the cap. Remove all of the rust and thoroughly clean and lubricate the parts. Next, you must replace the seals that allowed the water to move into the power shaft cavity in the first place. Remove the O-ring from the groove in the outer diameter of power shaft cap. Throw away the thrust washer and O-ring and install new ones when you reassemble the caliper. Use a flat blade tool to remove the seal from the bore of the power shaft cap. Now check the booting in the power shaft cap. The inner diameter must not exceed 1 507 inches or 38.28 millimeters. If the inner diameter is larger, replace it with a new one when you reassemble. Now, reassemble the power shaft assembly. I'll get you started. First, install a new seal in the power shaft cap. Place the new seal over the bore at the end of the power shaft cap that has a flange. The seal lips must be away from the power shaft cap. Use a press and steel plate to press the seal into the bore. Press the seal unit until it is even with the end of the bore. Install a new O-ring in the groove in the outer diameter of the power shaft. And apply grease to threads of the power shaft. The spline, the power shaft nut, all of the surfaces of the thrust washer. And the bushing and splines inside of the power shaft cap. From this point on, it'll be easy to complete the reassembly of the power shaft, the piston, and the O-ring. The manual will walk you through the steps. You shouldn't have any problem. Remember, replace all of the seals, washers, and O-rings in this procedure. Now that the power shaft actuator and caliper has been installed, place a pry bar on the automatic slack adjuster and push. If the action is smooth, you've got it. No more caliper drag. Now, install the caliper back a brake. This fix will help the caliper drag problem if you've properly diagnosed the problem.
I've encountered cases where the automatic slack adjuster is rusted to the power shaft on brakes built for 1990. Is there a way to get the slack adjuster off without tearing it up?
I'm glad that question was asked. I noted the text said that his slack built for 90. That's exactly right. This is brakes built for 90. Same problem. There's really a lot of you a puller. Now, it's a Tiger tool, but there are others out there. My tool on the slack adjuster. And that will the rustle. And then pull it off. No problem. A word of warning. Don't take a hammer if you don't have a puller. It'll do more damage. Now, after you've separated slack adjuster from power shaft, leave the rust on both the automatic slack adjuster and power shaft. Then apply anti-seize compound and continue with the procedure.
One final question about rust. How do you suggest separating a clevis that is rusted to the chain push rod? I don't want to cut off and damage the other parts.
Another question, but let's even take it a step further. Let's assume that there's rust on the clevis, mating the clevis pin to the clevis. First, apply penetrating oil to the entire assembly for the jammed clevis pin. Loosen the nut with a wrench. Take addition for working with the clevis. Now remove the clevis pin clips. If you have a puller that will fit, you can ease the clevis pins out, no problem. If you don't have a puller, brace the clevis to prevent movement that could damage the push rod of the chamber. Lightly tap the end of the clevis in with a hammer. Now, you'd be able to remove the clevis in from the clevis. Secure the push rod with a pair of vice grips and place a screwdriver in the clevis intake, making the rust seal. If the clevis still won't make loose, apply more penetrating oil and try again. If it's failed, it may be necessary to replace the push rod and the clevis. We hope that we've covered the issue that you questioned on. Rockwell International's air disc brake. Solid and dependable. And when cared for properly, will deliver years of safe service. But it must be cared for. Always rigidly follow the maintenance schedule and do the right shop and invent more tools. And use your manual. As I said at the beginning of the video, this manual will be the best tool you have on the bench when you're working with air brake system. And Ray, thanks for your help in this video. On behalf of Rockwell International, we want to thank you for your attention. And remember, this product is a result of your communicating with us. Keep it up. We're committed to providing you the best service possible. Thanks again.